So I briefly saw you at SEMA at the United After Party.
Yeah.
You were leaving, but I think you were telling somebody this is the like the fastest supercharged Ford GT in the world,
No,
or no?
Not determined yet. We hope so.
Okay.
Not yet. We haven't done any race events with it yet. We just got it finished.
Yeah.
So, yeah, we do plan to hit Texas Mile event. We're going to do the half-mile event with Motorsports. They started their Never Lift event that they're going to be hosting.
Okay.
So we'll go out and do that. And yes, the goal is to take the Supercharged record for the GTs.
Yeah.
And we think we have what it'll take to do it, but we still got to go out and make it happen.
Okay. Can you tell me about what the engine's got done to it? Stock displacement, or?
Stock displacement, it's pretty much fully built. Everything you can think of, built it and modified. Most unique part of the system is it's a non-throttled screw. You know, the fastest cars in the world are screw supercharged cars. They have just absolutely ridiculous torque response.
Yeah, the
very
top
brutal,
fuel blowing stuff.
Brutal in the way that the torque comes in, and so it's very difficult to beat the fun factor and drivability of it. And that was kind of the customer's goals. He didn't want a turbo car. We know we can make more power with turbo, but wanted to maintain that jaw-dropping kind of torque response and fun factor of driving the screw. And then so the next step becomes, how do we make elevated horsepower levels and mitigate and manage all the thermal problems, all the heat issues that exist with the screw supercharger. So that's kind of where this whole thing came from.
Yeah.
We didn't really set out to be different just to be different, but we set out with a goal to manage the the thermal aspects of the system, and this is just kind of what came out of that. But it's pretty unique just because of the fact that it brings fresh air in from the back. We've opened the clamshell up, direct fresh air to it, and it basically has fresh air coming into the blower. There's no throttle body here, so the problem with typically having a big throttle body there is these massive throttles that you need to get all the air into the front of a supercharger. Just a little bit of throttle opening gives you a massive torque response.
Oh, yeah.
So the issue with that is drivability. And the second issue with having a throttle there is a lot of guys will go through the traps in either drag racing or mile events if they're running a lot of boost, and everything's hot. We see as high as 465 degrees Fahrenheit coming out of the discharge of the blower at the end of a mile run. And the problem with that is if you go and shut the throttle at the end of a run, you've now just cut off all your ambient cooling coming into the front of it. It continues to expand and grow, and then they crash. So the discharge bearing plate will grow more than the inlet bearing plate. It tends to wedge the scrolls, and they'll hit on the outside of the case. They'll touch on the scrolls on the inside, and it can lock the whole blower up where you can't even start the car after the run. And not to mention the fact you need to put a $5,000 or $6,000 center section back into the blower.
Yeah.
So by not having a throttle there, we have massive amounts of ambient cooling moving through it at all times, even at the end of a run.
And that's just from the speed of the car and the air being forced through there? Or?
No, just it's constantly drawing air.
Oh, so it's still spinning, so it's still pulling.
Constantly spinning, so it's just an RPM device now. It has
Yeah.
no relation whatsoever to throttle position. Whatever RPM it's at, it's moving that amount of air.
Okay.
And so by air coming in, it's really there to maintain and keep it cool. The other thing we've done for cooling is, if you look here, there's a billet 5-axis water neck at the front. We've added one to the rear. Top port's a steam port. The bottom port goes over the thermostat housing. But those are O-ring, they bolt right down to the cylinder head, and then there's a 3/8 phenolic spacer that sets down over the top of that, and then the intake sets down. And what that does is it's a thermal barrier. It's a thermal isolator from the cylinder head heat all the way up to the intake. And we've seen the motor at 200 degrees and the blower case at 80 degrees Fahrenheit. So there's over a 100-degree differential between the cylinder head temperature and the blower case temperature, just idling, cruising around. So the benefit of that is our material starts off at over 100 degrees Fahrenheit lower than most typical supercharger applications. And so anyway, so the air comes in through the front inlet plenum, and this insert right here that we've added into the stock intake manifold's got a weld seam right across the top of the fuel rail. But basically it takes the air and directs it out the back. There's a flange right here that's got two rectangular ports. The top port is air out, the bottom port is air back into the plenum. And then in the middle that you have a difficult time seeing, just kind of covered up with everything that's there, is what we call our crossover. There's a billet part right there on the counter that's exposed, but essentially it takes the air out of the top port, transitions to a round inlet into the intercooler, goes through a 2,000 horsepower Garrett Honeywell core that we've hand built, goes through the core, and then tucked back in here there's a billet drive-by-wire throttle body. So there's a 4-inch drive-by-wire throttle body. It's all grafted into our billet component that we call a crossover that takes all the air back up into the plenum. So that's how it charges the plenum. When the throttle's shut from either idling or the end of a run, you're at 9,000 RPM and you shut the throttle, the blower doesn't stop moving all of that air. It's got a massive amount of air that's moving through it. And so if you just close the throttle and don't have a way to vent that air, it's going to fail the throttle body. It'll just probably fold it over. So there's 4 wastegates on the back of the intercooler. And we use wastegates just simply because that way we can duct the air where we want it to go. And 3 of them are vacuum actuated, just blow-off valves. The 4th one, though, we have control over both sides of the diaphragm, and we're doing boost control with it. So it's pulleyed for 40 pounds of boost. We can actually dump all the way down to 3 pounds. And it just allows us to manage the power based on the tire we're on, the track surfaces, what gear we're in, what percentage of alcohol we're on, which it'll run 93 all the way to E98, anywhere in between. And then if we want to, we can also put pure methanol in the tank, just straight M1. There's a Kinsler mechanical fuel pump that's grafted on the back of the stock oil pump. So when the car's driving around, it's just no electric pump running. It's just on the mechanical pump. That's why we've got 2 of the Kinsler regulators, just because of the amount of fuel volume that we're pushing to it. Because of the fact that we've got all these billet components with airflow through the center, we couldn't use the stock cross member. So I needed a place to put ice water also. So this is our 10-gallon structural ice water tank that supports the shock towers and still does the transmission pickup. These cars typically run, the frame typically runs about 220 degrees Fahrenheit in a 70-degree weather day, just because of the exhaust heat that's coming off of it. So we still run a phenolic spacer just to separate our water from that. And then with ours, we did all 321 stainless custom exhaust, and it's got a plasma flame spray deposition coating on it, but then we do an Inconel shield over that. And that actually dropped our frame temperature from 220 down to 110. But still, 110 is more than we want getting into our water, so we run the phenolic spacer between it and the transmission. Big electric billet pump that's pushing water into the back of the intercooler. Everything with the intercooler and all our cooling system, all self-purchased. All the lines are at the front and at the top. So it basically forces all the air to the top of it and out. There's custom hard lines that run all the way down the side of the car, through the heat exchanger and all the way back into the tank, just to keep everything cool there. We've got a lot of sensors in it. So for example, we monitor our case temperatures, the front and rear. So that's measuring the material temperature of the case. And if we see them deviate from one another or elevate, then if we need to, we can put fuel in upstream through the blower, just help cool the scrolls down. That's also why we have the blow-off disc. There's quite a bit of homogenized air and fuel. If we were to get a unwanted backfire, ignition cut, or something like that were to occur when we didn't want it, there's a possibility of a backfire, so that's why we've got the disc on it. Try to avoid that at all costs, but things happen, so we want to try to prepare for it. All the powder coating, what's that?
Those pop out.
Yeah, they would rip and blow open. And then we did these ducted shields just to protect the deck lid. I mean, the deck lids are about 40 grand on these things, so we'd prefer not to put a hole through it. Just packaging, nice to be able to put the shock mounts on it. It is going to get some cooling through the water, so can help take some heat out of those. All the powder coat is the factory original powder coat. Moroso originally built all the tanks for Ford. They actually had an old one sitting on the shelf, so it allowed us to make our coolant tanks and do a recovery tank. And this actually runs all the way to the front windshield, so if it pushes water, it's kind of road race stuff. If it pushes water, the driver will see it. It'll get all kinds of other warning alarms if it's overheating, but this is another indicator. Got our big breather system on it, the dash 16 line. All military, auto sport, quick disconnect, tight connectors. Most of these are all mil spec. We're a tier 1 master Motec dealer. It's kind of what we specialize in. So it's got a Motec M150 with our custom firmware package in it, specific for this particular car and application. It's got a Motec PDM15, which is doing all of our power delivery, fusing, and relaying. Now it's all solid state, and they communicate to each other in the keypad inside through a CAN bus. So all of them are talking amongst each other in logic commands and programming. The ignition that we're running, there's actually 2 boxes, one on this side and one on the inside. It's a M&W CDI, and we actually run about 150 millijoule just driving around, and then when we go into boost, it'll bump it up to 250 millijoule. It's a pretty hot ignition system. We do have a Motec E816 expander on it just for more inputs and outputs. There's an EGT module underneath the tank that's picking up all of our EGT information. The rails are custom. They look pretty basic, but it's a 5-axis part just because the injectors are on a compound angle. They're canted out and in towards each other. But in a nutshell, that's the majority of it. The car's drive-by-wire now. It never had cruise control. We added cruise control to the car. So if you look at the keypad, the front 3 buttons on the keypad are cruise control. We've given him a button for if he changes his tires, goes from the slicks to the street tires. Just all he has to do is push a button to reset all the circumference values for the traction control system. We've added really high-end wheel speed sensors all the way around and custom trigger wheels so that it now has launch control and traction control. It's all race-grade Motec level stuff. That's pretty much it. There's other things going on, but those are the major parts of it.
Any future upgrades you're looking at doing?
We'll probably put an oil cooler on it for the blowers to help cool down the front of the case. We've already got it wired for it right here. We just haven't added that to it yet. It's extremely loud. It's got a serious blower whine to it because the wastegates are open. Most people love it. Most people walk up to us and say things like, 60 years old, and I've never ever heard anything like this. What is going on?
Yeah, I heard you leaving SEMA Ignited, and it sounded like like an F-22 Raptor going down the runway or something.
Absolutely nuts. It's serious blower whine.
Okay.
Sounds pretty neat. Most people like it, but it is a street car, and
daily that could get
loud
kind of
things
old.
like that can get annoying. So
yeah.
we're going to do a muffler system in the back just to handle some of the whine aspects of it, quiet down a little bit for street applications. But we'll have the ability to do it either way, make it loud or make it quiet. And, now it's just go out and have fun with it.
All right. I know it's mostly aluminum. Is there any weight reduction done on here? Anything
Not
serious
really.
in here?
You know, the cars aren't that light to begin with. They're in the 3,500 pound range. We're right about that same thing right now because we have done some things to remove weight. The factory exhaust systems are extremely heavy on these cars.
No, but the blower and all that
like
water adds
we've
a
added
lot
10
though.
gallons of water to it. You know, there's 80 pounds right there that we just added. So bigger blower, more aluminum. So we're not far off from original. We're pretty close.
Okay. Yeah. Cool. Love the car.
Yeah, thank you.